Topic 7.4, solving problems involving independent events. The rule for the probability of two independent events can be extended to three or more independent events. When calculating the probability of multiple independent events occurring, multiply the probability of each independent event together. For example, let's assume that the green die was rolled first, the blue die was rolled second, and the red die was rolled third. What is the probability that we would roll a 2, a 3, and a 4 in that order, one at a time? Well, the probability of rolling a 2 with this green die would be 1 over 6, or 1 out of every 6 times. There are 6 sides with the numbers 1 to 6 written on a typical die. What is the probability of rolling a 3 on the next one? Well, the probability would be the same. The number 3 is 1 of the 6 sides, and the red die having the number 4 would also have a probability of 1 over 6. Now, we can just simply multiply these probabilities together to figure out the probability of rolling a 2, 3, and 4 in that order. 1 over 6 times 1 over 6 times 1 over 6. So remember, when we're multiplying, multiply straight across. 1 times 1 times 1 is 1. 6 times 6 times 6 is 216. So the probability that we would roll these values one at a time in that order is 1 out of 216. Let's take a look at another problem. A probability experiment involves tossing a coin, rolling a die labeled 1 to 6, and spinning the pointer on a spinner with 3 congruent sectors colored pink, purple, and yellow. Use a tree diagram or a table to find the probability of each event. Tossing heads, rolling a 2 and landing on purple. Tossing tails, rolling an even number and landing on yellow. Tossing heads, rolling a 1 or a 2 and landing on pink. Now, using a table this time, what we can do is we can label the events. So let's call the first event, which is tossing a coin, 1. We'll call the second event, which is rolling the die, 2. And we'll call the third event, which is spinning the spinner, 3. Now, the first event has 2 possible outcomes. It's got heads or tails, that's it. The second outcome has 6 possible outcomes. They are the numbers 1 through 6. And the third event has 3 possible outcomes, and they are P for pink. Actually, we'll call it PI, because purple also begins with P. PU for purple, and Y for yellow. So those are all of the possible outcomes from each event. Now, what are the probabilities of these situations? So the first one is tossing heads, rolling a 2, tossing heads, rolling a 2, and landing on purple. Well, the probability here is 1 over 2. Probability here is 1 over 6. Probability here is 1 over 3. So what we can do is multiply these together. 2 times 6 is 12. 12 times 3 is 36. The probability of all those 3 things happening is 1 out of 36. How about the probability of tossing tails, rolling an even number, and landing on yellow? Well, if we toss tails, land on an even number, so that would be 2, 4, or 6, and land on pink, our probabilities would change slightly. So this one would be the same, 1 out of 2. This one would be 1, 2, 3 out of 6, right? Which is half. So that would also be 1 out of 2. And pink would be 1 over 3. So 1 times 1 times 1 is 1. 2 times 2 would be 4. 4 times 3 is 12. Probability of tossing tails, rolling an even number, and landing on yellow is 1 over 12. And finally, tossing heads, rolling a 1 over a 2, and landing on pink. So we're going to toss heads, and land on 1 or 2, and land on pink. Well, that would be 1 over 2 times 2 out of 6 possibilities. 2 out of 6 is also equal to 1/3, right? It's an equivalent fraction. I just simplified it. And pink is 1 out of 3 as well. So this would be 1. 2 times 3 is 6. 6 times 3 is 18. So the chances of that happening would be 1 over 8. Let's try a couple more problems. Number 1. Nadine, Joshua, and Shirley each have a standard deck of playing cards. Each student randomly draws a card from the deck. Find the probability of each event. A. Each student draws a heart. Well, there are 4 suits in a standard deck of cards, and that would mean that 1 out of every 4 cards should be a heart. So for each student, the probability would be 1 out of 4, and we can multiply these probabilities together to find the probability of all of these independent events occurring. So that would be 1 over 64. B. Nadine draws a spade, Joshua draws a spade, and Shirley draws a red card. Well, the probability that Nadine draws a spade would be 1 over 4. The probability that Joshua will draw a spade is 1 over 4. And the probability that Shirley will draw a red card would be 2 over 4. 2 out of the 4 suits are red, hearts and diamonds, which is the same as 1/2. Simplified. And this would be 1. 4 times 4 is 16, times 2 is 32. So 1 over 32. C. Nadine does not draw a heart. Joshua draws a black card, and Shirley draws an ace. Well, if Nadine does not draw a heart, that means she's either going to draw a spade, a diamond, or a club. So that would make this probability 3 out of 4. Only one of them is a heart. Joshua draws a black card. Well, half of the cards are red, half of the cards are black. So that would be 1/2. And Shirley draws an ace. Well, there are 13 cards for every suit, and one of those cards is an ace. So in a standard deck of cards, there are 4 aces, one for each suit. So that would be 4 over 52 cards. 4 cards out of 52. Now we can actually simplify that to 1 out of 13. So 4 cards out of 52 are aces, but if we divide each of those by 4, we get 1 card out of 13 that is an ace. So we can actually use that as our probability here. Okay, and let's see, 3 times 1 would be 3. And this would be 104. So 3 over 104. And let's try the last question. Preet writes a multiple choice test. The test has 5 questions. Each question has 4 possible answers. Preet guesses each answer. Find the probability of each event. A. She answers all 5 questions correctly. Well, if she's guessing here and there are 4 possible answers, then the chances of her guessing the correct response will be 1/4. And there are 5 questions she's going to be guessing for. So that would be 1/4 times 1/4 times 1/4 is 1/4 times 1/4, which would be 1/1024. Those are her chances of getting all 5 questions correct. B, she answers only the first 3 questions correctly. So the first 3 questions are correct. 1/4 times 1/4 times 1/4. And, well, if the first 3 questions are correct, then the last 2 would be incorrect. Well, the chances of getting an incorrect answer would be 3/4. So 3/4 for the 5th question as well. This would be 9 up here, and this would be 1024 as well. And finally, she answers all 5 questions incorrectly. Well, if she's answered incorrectly, the chances are 3 out of 4 that will be the case. So if each one of the 5 questions is answered incorrectly, the chances are 243/1024.